Hello there. My name is Michael Tawonga Kamanga, chemistry teacher from one. I'm here to take you through uh, laboratory safety measures, and I'll focus much on the chemistry lab. Um, the idea of chemistry lab is very important because the lab is part of science. Because in science we have to test the natural situations, the natural phenomena. We are trying to provide answers to the problems which we find through scientific inquiry. So we cannot do that without using a lab. So a lab is very important as far as the learning of chemistry is concerned. So in this lesson, I'll take you through the lab. In the other lessons, I'll take you through the safety measures uh, for the lab and even the hazard symbols. So please be with me as I'm taking you through the chemistry lab. Now, we will begin by understanding what the lab is through a definition. So we'll define what is the lab and the idea of the lab. How are we like why are we talking about the lab? That is the importance of the lab. So since the subject is chemistry, no wonder we'll be looking at the chemistry laboratory. So first things first, on the definition of a chemistry laboratory, this is a well-equipped space designed for conducting experiments, research, and analysis involving chemical substances. Allow me to take that again. A chemistry lab is a well-equipped, it should be well-equipped space designed for conducting experiments, research, and analysis involving chemical substances. That is a chemistry lab. So, only a brief, let's say the brief characteristics of a lab, it should be a well-equipped space which is designed for conducting experiments, research, and analyzing involving rather analysis involving chemical substances. So this is in general. So what are the types of laboratories? Before we look at the types of laboratories, you can also come up with your own definition of a lab in your own words. How can you define a laboratory? Now, on types of laboratories, we have the first one, which is known as a formal laboratory. A formal laboratory. So what is this formal laboratory? A formal laboratory, it has the following description. It is a highly structured environment designed to conduct scientific research, experiments, or testing according to strict protocols and regulations. These labs are often found in academic institutions, research centers, industrial facilities, and government agencies. So a formal lab is a highly structured environment which is solely designed for research, experiments, or testing. So it is a highly structured environment. So what are the key characteristics of this formal lab? On regulatory compliance, formal laboratories must adhere to strict safety standards, legal regulations, and guidelines such as good laboratory practices, GLP, or ISO standards. This ensures the accuracy, reliability, and reproducibility of results. So it should have regulatory compliance as the first characteristic. The lab should also have standardized procedures. So experiments and tests are conducted according to established protocols, often documented in standard operating procedures, SOPs. This ensures consistency and allows for the replication of results. So yes, a formal lab, should have standardized procedures, regulatory compliance. In addition, highly specialized equipment. A formal lab should have highly specialized equipment. So formal labs are equipped with advanced, often expensive instruments and tools such as mass spectrometers, chromatographs, a high-performance computer. The equipment is regularly calibrated and maintained to ensure precise measurements. So a formal lab, the key characteristics: regulatory compliance, standardized procedures, highly specialized equipment as well. And on top of that, a formal lab, it should have documented processes, controlled environment, professional staff. So a formal lab, as far as documented processes, all activities from experiment setup to data analysis are meticulously documented. This includes maintaining lab notebooks, generating detailed reports, and adhering to data integrity standards. On the controlled environment, the lab environment is carefully controlled with considerations for temperature, humidity, ventilation, and cleanliness. Access to the lab is often restricted to authorized personnel. So a formal lab is a controlled environment. No one can just go into the lab. No wonder the access is granted. It is restricted to authorized personnel. Professional staff. Formal laboratories are staffed by trained scientists, technicians, and support personnel, all of whom have specific roles and responsibilities. Continuous professional development and training are common in these settings. Safety and emergency protocols. Safety is paramount with strict enforcement of safety protocols, regular safety drills, and readily available safety equipment like fume hoods, fire extinguishers, and personnel protective equipment, PPE. For example, a pharmaceutical research laboratory developing new drugs follows strict regulatory guidelines. Every step from the initial chemical synthesis to clinical trial preparation is documented and validated to ensure compliance with regulatory bodies like the FDA. So yes, Safety and emergency protocols are needed in a formal lab. They are always observed. So as you can see there, there's a nice diagram of a pharmaceutical laboratory. You see it is spacious, there's a lot of space, a lot of equipment, advanced equipment, and this lab is a formal lab. So indeed a formal lab, it has its own key characteristics because it is solely designed to for experiments to be conducted. So this is a pharmaceutical laboratory. Now, the second type is informal laboratory. Informal laboratory. So how can we describe an informal laboratory? So this informal laboratory is more flexible and less regulated environment where experiments and creative scientific exploration can take place. These labs are often found in educational settings, home-based workshops, or community spaces. They prioritize innovation, learning, and hands-on experience over strict adherence to formal protocols. So, what we are saying that here is that an informal lab is more flexible than formal lab, and it is less regulated environment. That is why an informal lab you can find it in an education setting, let's say at a school, because it is more flexible and the main purpose is for learning and hands-on experience. So that is an informal lab. And what are the key characteristics of the informal lab? The key characteristics of an informal lab. Well, we have flexibility in procedures. In a formal, remember, uh, we have to be strict in procedures, but in informal, there's flexibility in procedures. So informal labs allow for more freedom in the approach to experiments, while general safety and methodological principles are followed. There is more room for improvisation and experimentation. So yeah, the procedures are always flexible because the more room is allowed for improvisation and experimentation. And in an informal lab, we have basic equipment. The equipment in an informal lab is typically less sophisticated and more accessible. Common items include basic glassware, simple microscopes, and household items. In some cases, DIY or improvised tools are used. So an informal lab, you don't have, let's say, advanced equipment. You can also have basic equipment. So the basic equipment, you can also wish to improvise on the equipments as well and on the tools which you are supposed to use. So an informal lab indeed has basic equipment. It also has creative and educational focus. These labs often emphasize learning and creativity, encouraging experimentation, trial and error, and exploration of new ideas. They are common in schools, hobbyist groups, and maker spaces. In terms of documentation, while some level of documentation may be maintained, it is usually less formal. Lab notes might be kept in a notebook or a digit format, but without the rigorous standards of formal labs. Casual environment. The environment is more relaxed, often without strict control over factors like temperature or humidity. These labs may be located in classrooms, garages, or community centers. Then there's also diverse participants. Remember, the formal lab, it is always strict to the lab personnel. But informal labs often involve a mix of participants, from students and hobbyists to amateur scientists. The emphasis is on inclusivity and accessibility rather than professional credentials. So usually you are always free to use the informal lab, while for the formal you are always restricted because it is open to the professional personnel. Then the safety awareness. While safety is still important, the protocols in informal labs are generally less strict. Basic safety measures like wearing goggles or gloves are encouraged, but the level of enforcement varies. So yeah, we are focusing on the safety of the users of the lab, but here we are only focusing on basic safety measures, unlike the formal lab. So example, a high school chemistry lab where students conduct simple experiments like creating vinegar and baking soda reaction in a classroom setting. The focus is on understanding basic scientific principles rather than achieving precise publishable results. So as you can see here, the students are having fun in an informal lab. They are conducting basic experiments for the sake of knowledge and the hands-on experience. It's not that they are focusing on achieving precise results and the publishable results. So yeah, this is a school setting and this is an informal lab. So let us compare between a formal and an informal lab. There's regulation and structure. Formal labs are highly regulated and structured, while informal labs are more relaxed and flexible. For the equipment, formal labs use advanced specialized equipment, while informal labs often rely on basic or improvised tools. Purpose: formal labs focus on precise, reproducible results, often for professional or commercial purposes, while informal labs emphasize learning, exploration, and creativity. Documentation: formal labs require thorough documentation, while informal labs may keep simpler records. Safety: formal labs enforce strict safety protocols, while informal labs maintain a more basic level of safety awareness. Now, yes, a lab plays a crucial role in the study of chemistry. It serves as the primary environment where theoretical knowledge is applied, tested, and expanded through experimentation. So here is an overview of the various roles a laboratory fulfills in the study of chemistry. So we are looking at the roles of the lab in the study of chemistry. Number one is experimental verification, where we are testing the hypothesis. So in chemistry, theories and hypotheses are often derived from mathematical models or previous knowledge. The laboratory is where these hypotheses are tested through experiments. allowing scientists to verify, refine, or refute them. Then there's observation of phenomena. Many chemical reactions and phenomena are observable only under specific conditions that can be precisely controlled in a laboratory setting. This enables the study of reactions that might be difficult or impossible to observe in natural settings. So one role of a lab in chemistry is for experimental verification. And another role is for hands-on learning, practical skills development for students and researchers. The laboratory provides a hands-on learning environment where they can develop essential practical skills such as measuring, mixing, and handling chemicals, using instruments, and following experimental protocols. Application of theory. The lab bridges the gap between theory and practice, allowing students to see firsthand how the concepts they learn in the classroom, such as the reaction kinetics, thermodynamics, and molecular structure, manifest in real-world scenarios. Then chemical synthesis and analysis. This is the third role a lab plays, that is a chemistry lab. So creating new compounds, one of the fundamental activities in the chemistry lab is the synthesis of new chemical compounds. This is vital in areas such as pharmaceuticals, material science, biochemistry, where new molecules of specific properties are constantly being developed. Then analyzing chemical composition. Laboratories are equipped with analytical instruments like spectrometers, chromatographs, and titrators. That allows chemists to determine the composition, purity, and concentration of substances, which is essential in quality control, environmental monitoring, and research. So this falls under chemical synthesis and analysis. Then we have innovation and discovery, that is research and development, R&D. Laboratories are hubs of innovation where chemists conduct R&D to discover new materials, reactions, and processes. This work often leads to breakthrough in areas such as energy, storage, catalysis, and nanotechnology. Then there's experimentation and exploration. Labs allow for the exploration of ideas, hypotheses in a controlled environment. This freedom to experiment is crucial for making unexpected discoveries that can lead to new fields of study or technological advancements. So this falls under innovation and discovery. Then safety and risk management. Controlled environment. The laboratory provides a controlled environment where potentially hazardous chemical reactions can be conducted safely. This includes the use of fume hoods, safety protocols, and personal protective equipment to protect researchers and students. Then there's waste management. Laboratories are designed to safely handle, store, and dispose of chemical waste, minimizing environmental impact and ensuring compliance with safety regulations. Then standardization and reproducibility, accurate measurements. That is, laboratories are equipped with precise instruments that allow for the accurate measurements of quantities like mass, volume, temperature, and concentration. Then there's also reproducibility of experiments. By following standardized procedures and using controlled conditions, laboratories ensure that experiments can be reproduced by other researchers, which is fundamental to the scientific method and peer review process. Another role is for teaching and learning rather than training, where you have educational labs in education settings. They provide students with the opportunity to apply theoretical knowledge and learn scientific methods and critical thinking skills. Professional training laboratory also serve as a training grounds for aspiring chemists, providing them with the experiment and expertise needed to pursue careers. Then collaboration and communication. You have collaborative research and data collection and sharing. So lab often bring together teams of scientists from different disciplines, fostering collaboration and on the data collection and sharing. Labs are central to the collection, analysis, so the data generated in labs forms the basis of scientific papers, patents, and presentations that communicate findings to the broader community. Then there's simulation of real-world conditions, that is environmental and industrial applications. Labs can simulate real-world conditions such as temperature, pressure, and chemical environments, allowing chemists to study processes that are relevant to industries like petrochemicals, pharmaceuticals, and environmental science. Testing and quality assurance. Laboratories are used to test the stability, reactivity, and quality of materials and chemicals under various conditions. Supporting technological advances, that is the last role of a chemist lab. There's development of new technologies. The research conducted in chemistry laboratories often leads to the development of new technologies such as improved batteries, medical diagnostics, or sustainable materials. Innovation in chemical processes. Labs are where new processes are developed. So as you can see in summary, laboratories are essential to the study of chemistry, providing a space where theory meets practice. New knowledge is created and future chemists are trained. They are the backbone of scientific inquiry, driving innovation and discovery across all areas of chemistry. So they are very, very important. They are the backbone of scientific inquiry, driving innovation and discovery across all areas of chemistry. So I've looked at what a lab is, the types of lab, the key characteristics of the two types of labs, and the roles, the different roles a chemist lab plays in studying of chemistry. Okay, so reaching this far, there's an activity here which you are supposed to do. And remember to provide your answers in the comment section. And you can as well compare your answers with my suggested answers. Question number 1. What is the primary function of a laboratory in the study of chemistry? What defines a formal laboratory and how does it differ from an informal laboratory? List 3 characteristics of formal laboratory. And what are some typical environments where you would find informal laboratories? And explain the purpose of standardized procedures in a formal laboratory. For any questions, please, there's the WhatsApp number here, or help@xulendo.org, or visit Xulendo online, xulendo.org. Please, we need your feedback. For the references, I've used Excel and Succeed. Junior Chemistry, that is book 1. Then Achievers in Chemistry, book 1. Jungle Chemistry, book 1. Samuel Kalea Chemistry, book 1. For the photos, these are the links for the photos, and feel free to visit the links. Well, until we meet again in the next lessons, bye-bye.